Hello student, welcome to Study Circle YouTube channel. Myself Raja Chakravarti. Now today in this video we will discuss the important questions of work, energy and power of class 9th. Actually I have prepared the 10 questions. As you know that your final examinations is coming very soon and DAV वाले लोग को तो 7 कोई साइंस है, तो इसी को पॉइंट ऑफ व्यू में रखते हुए 10 क्वेश्चन इस चैप्टर से, थियोरेटिकल क्वेश्चन इस चैप्टर से हमने बनाया एंड यू बिलीव दैट आउट ऑफ दिस क्वेश्चंस डेफिनेटली 3 or 4 क्वेश्चंस इज गोइंग टू कम फाइनल एग्जामिनेशंस. और अगर इफ देयर इज सम एक्स्ट्रा क्वेश्चन विल आल्सो कम, तो अगर आप ये 10 क्वेश्चन आपको कंसेप्ट अगर क्लियर है तो आप कोई भी थियोरेटिकल क्वेश्चन इस चैप्टर से डेफिनेटली कैच इन द एग्जामिनेशंस. So okay, now start with the first these 5 questions. Then after completing that, we will also discuss the next 5 theoretical questions, and after that, in the next videos, we will also discuss the numerical question of this chapter. So now first understand these 5 questions. First is that what is work? So according to physics, we know that if you apply a force in a body, suppose if it is a body and if you apply a force in it, and as a result of that force if it is displaced, then you can say that work is said to be done. So according to physics, work is said to be done when you apply a force on a body, and if a body displaced from its position or if a body may come in motion, then we can say that work is done. And mathematically work done is equals to F into S. So that is the work done formula, and its unit is joule. Also you will write the unit, it will better impression in your answer, create a better impression. That unit is your joule. So that is the work. The work is said to be done when a force is acting on an object, and if object displaced from its position, then work is said to be done. Second part of this question is write an expression of the 3 cases of work. There are the 3 cases in your syllabus we have to read. The first case, when a force is acting on the body and the body is moving in the direction of force. So that work done equals to F into S. That is the first case. Second case of work done, suppose if a body is lifted to a certain height. That is the second case of the work done. That is the second case. That is said to be work done against gravity. That is the second case of the work done. And when suppose the body has a mass m, so in that case the work done on the body that is equals to, and if it is lifted to height h, so that is force into displacement. Here force is equals to weight of the body, so that's why mg is the weight and into height. That is the second case of the work done. And the third case for the work done, that is the, if suppose force is acting in the direction of this and the body move in this directions, displacement of the body is in this direction, so if there is some angle between them, suppose this angle is theta, then work, it is said to be work done obliquely, and that work done is equals to F into S cos theta. So these are the 3 cases of the work done when a force is acting on the body and body is moving in the direction of force. Second, work done against gravity, that is mgh. And third, work done obliquely, if there is some angle between the direction of force and the direction of motion of the body, that is Fs cos theta. These are the 3 formula for the work done. And that is the answer to the first question. Now come to the question, second questions. Your second question is give an example of negative work. Work done is 3 cases: positive, negative and zero work done. तो पॉजिटिव मीन्स जिस डायरेक्शन ऑफ फोर्स लगा उसी में अगर बॉडी मूव करता है पॉजिटिव होता है. जीरो वर्क होता है इफ द बॉडी if the force is acting on the body in the perpendicular to the direction of motion. But negative work means if the force is acting on this body in this directions, but the displacement of the body is this direction, that is said to be negative work. So here we have to give an examples. The example of negative works means when you lift a certain object to a certain height, suppose If an object is lifting to a certain height, the force acting on the object, that is by the gravitational force, that is in the downward directions, but object is moving upward directions. So here work done by gravity is zero. Work done by gravity is here negative. So the example of work done means negative work done when a body is lifted to certain height against the gravitational force, then work done by gravity is said to be negative. Okay, that is the example of work done, negative work done. Now the third question is your important question is define 1 joule. So as you know that unit of work done is joule and work done equals to, you know that, force into displacement. So 1 joule means work done when 1 joule, if 1 Newton of force is acting on a body and such that its displacement is 1 meter, then work done equals to your 1 joule. That was 1 joule equals to your 1 Newton meter. मतलब अगर 1 न्यूटन बॉडी पे फोर्स लगाते हैं आप, if the force is acting and body will displace, if it is 1 meter displacement अगर हो रहा है, then work done is equals to your 1 joule. Is it clear? So if you have to define 1 joule, so 1 joule of work done means when a 1 Newton of force is acting on a body and body displaced by 1 meter, then you can say that work done is equivalent to 1 joule. Now come to the next questions, that is your fourth questions. Define kinetic energy. Kinetic energy is the energy possessed in the body due to its motion, by virtue of its motion. When a body is in motion, motion के कारण जो body में कोई energy जो आता है, that is said to be kinetic energy. So kinetic energy defined as the energy possessed in the body by virtue of its motion is said to be kinetic energy, and kinetic energy is equals to mathematically half mv square. Half into mv square, that is the formula for the kinetic energy. Here in this question, that is also, it is derived its formula, we have to derive it. So in the previous video of the chapter, I have already given the derivation of kinetic energy, so we will see from that. Okay. The next is that state law of conservation of energy and verify it. So according to law of conservation of energy, energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. That is the law of conservation of energy. And verification matlab we have to show that the total energy of the body is remains constant, and that verification also I have given in the last video of chapters when I discuss the chapters. So already you will search it in my channel. They will get the derivation of kinetic energy, and you will get also the law of conservation of energy derivation. So these are the two important derivations that you have to see from the last videos. You will search in the channel, you will get that videos. Okay. So these are the 5 important questions. Next 5 we will also discuss the 5 most theoretical questions, or 5 theoretical questions we will discuss. So I think it is okay, and if you have any doubt in any questions, then you WhatsApp me, then I will give your again the if you want some same notes for these questions, I will also give it. So WhatsApp me. Okay. Now the continuation of the important questions of work energy power. We have discussed the 5 questions. Now we will discuss the next 5 questions. 6th one, define power and what do you mean by watt? 1 watt. So power is defined as rate of doing work. Power is equals to your rate of doing work, and it is equals to work done by time taken to do the works. It is defined as the power is defined as rate of doing work, and it is equals to work done by time taken, and unit of power, that is your watt. And 1 watt, what do you mean by 1 watt? The next question is 1 watt is equals to work done means 1 watt means 1 joule when the 1 joule of work is done per second. Means if the 1 joule is work is doing in per second, then the power is equals to your 1 watt. 1 watt is equals to 1 joule per second. So that is the answer for the 6 questions. Now the next one is that the 7th question. What is the work done on a body moving in a circular path? When a body moves in a circular path, its work done is 0. Because the force acting on the motion of the body, that's why its work done is 0. So work done is 0 here. When a body is moved in a circular path, the work done will be always 0. The next one, what happens to the kinetic energy here? What happens to the kinetic energy when the velocity of the body is double at constant mass? So since we know that kinetic energy is equals to half mv square, that is kinetic energy is equals to half mv square. So now the question is, what happens when the velocity of the body is double at constant? Mass remains constant, but velocity is double. So when the place of v, the new velocity, if it is, suppose new kinetic energy, when the velocity is double, in the place of v, it is 2v square. That is the new kinetic energy, suppose it is denoted by Ke1. So that will becomes 1 by 2 m into 4v square. So that will be half, or 2 times it will get cancelled out. Or you can say that half into m into mv square into 4. That means original kinetic energy दिया था आपका, और अभी क्या होगा, न्यू काइनेटिक है 4 टाइम्स. दैट मींस द न्यू काइनेटिक एनर्जी इज 4 टाइम्स इट इज दैन ओरिजिनल. इट इंक्रीजेस बाय 4 टाइम्स. इज इट क्लियर? सेकंड क्वेश्चन इसी का था, द मास ऑफ द बॉडी इज डबल बट द वेलोसिटी इज रिड्यूसेस टू हाफ. नाउ फॉर द सेकंड पार्ट, सिंस वी नो दैट ओरिजिनली काइनेटिक एनर्जी द मास इज m and velocity is v, the half mv square. Now the new kinetic energy Ke1, suppose it is, mass of the body is double. That means in the place of m we can write 2m, and in the velocity is reduced to half. So in the place of v we can write half v square. So now if you calculate the half this m and v square, और यहाँ पे क्या हो गया, एक 2 और यहाँ पे 4. So that will be, it will be get cancel out. So that means it is half mv square into 1 by 2. Means original था आपका ये, and into it is 1 by 2. That means the new kinetic energy. So that means Ke1, new kinetic energy, is half times of Ke. मतलब the kinetic energy become half when the mass of double and velocity is reduces to half. Is it okay? Now the next question. Define potential energy. The potential energy of a body means the energy possessed in a body by due to the change in its position, change in shape and size. When a body is lifted to certain height, so that it has some potential energy. So that potential energy is equals to same as the work done against gravity, and that is equals to your mgh. And when a body is lifted, the potential energy is mgh. If you stretch a rubber band and release it, it has some energy. That energy is also said to be potential energy. So when you change the shape of the body, when you lift a certain body to a certain height, so the energy possessed in the body is said to be potential energy. Now last one, what do you understand by the unit of electrical energy? Electrical energy, we know that power equals to work done by time. The or energy by time, जितना work done होगा उतना ही energy consume होगा. That means energy equals to power into time. So when power is in watt, time is in second, energy come in joule. But for electrical energy, we calculate the energy in kilowatt hour, because joule is very smaller for the electrical energy. So unit of electrical energy that is equals to kilowatt hour. Means power must be in kilowatt and time must be in hour. Then we can say that the unit of electrical energy is kilowatt hour, and 1 kilowatt hour that is equals to 1 commercial unit. जो हमारा मीटर में जो यूनिट जो उड़ता है, जो when you use the electricity, हमारा जो इलेक्ट्रिकल मीटर में जो यूनिट जो उड़ता है, that is the एक यूनिट, जब 1 किलोवाट आवर एनर्जी कंज्यूम होता है, then हमारा 1 यूनिट आपका मीटर रीडिंग होता है. Okay? Is it clear all of you? Thank you.